This is the second part of my talk. Today I'll be discussing on functions. I'll be talking about different functions that we already have in Python, and talk about the modules, which are collection of functions. I'll talk about packages, but not maybe today. We'll discuss about packages tomorrow and the day after tomorrow. So I would like to say that the functions that we can use here, most of the functions, all the functions are grouped in some modules. And some of the modules are already available. If you just download basic Python and install your Python, you already get some modules, a huge number of modules. If you install your basic Python from python.org, or if you are in Linux. Some modules and packages are not available in the default installation, but that is why you go for distributions like Python XY or Anaconda that gives you some extra modules and packages like NumPy, SciPy, Matplotlib, Pandas, Bismap that we will be talking about in the successive classes. And even there are many packages which are not included in either Python XY or Anaconda. If you need them, you have to install them following their instructions. Most of the packages can be, many of the packages can be installed using pip technique. Okay. So today I'll just first concentrate on the basic modules which are available in basic Python, and these will be discussed later on. So if we type in our interpreter, this kind of a thing, modules already installed in your Python. So so for beginners, most of the modules are of no use. So I'll be basically discussing about some very common modules which are used by almost everybody. Those are built-ins: math, CMath, time, random, and I. Among them, random has already been discussed by Opijit. So I don't think I have much to discuss on random. I'll just show one or two examples. So
could you just slowly slow down a bit, because sometimes your voice is breaking. At least.
Okay.
Slowly, I think people will be able to get what you are saying. I don't have much of a problem here. But, maybe some others are having some network problems.
Okay. Thank you. So I will be discussing on these modules like built-ins, math, CMath, time, random, and RE. Of them, random has already been discussed by Abhijit. I don't have much to do. I'll be showing one or two examples. So let's go to the modules. So as it has been told many times that there is a concept of namespace. So let me see that if you go to Python interpreter and you type dir, you get some things. These are the things that are available in your namespace, and usually namespace is a technological term. What I prefer to use, that namespace is something like a tabletop. The things that are available in your tabletop, what can they be? Some of them are variables that you created, say x equal to 2, x equal to 5, y equal to 3. Those are the variables that you have created. So these variables are there in your namespace. You have created those names. You may have defined some functions. So there may be some functions, or there may be some modules which contains function. Now, even if you don't do anything, just open the Python interpreter, then one of the module is always present, that is called built-ins. It's an inbuilt module. In my Python, I don't know why, in Anaconda, the Python comes with Anaconda, it's called built-in. The last ace is not there. Okay, you have to see that. So if you, this thing, I can give a demonstration. So just type dir. built built-in. In my distribution is built in. If I give that, see, it gives a long list of functions and other things those are available. And I can't see them very well. So I have written a small little program to see them a little bit better. Uh, so I run this here. I copy this from there and run this in the directory. And then show you what it is. So you see, now I can see the functions a little better. So let us see, what did I do? When I ran dir built-in, it actually gave me a list. So I stored the list as A. Then I did what you call a list comprehension. I selected only those elements of the list whose first, I know it's a list of strings that you can see that the things, there are of strings. So it's a list of strings. So I only select those strings whose first character is not equal to underscore, because you see there are some things which will start with underscore. So I want to neglect them. And there are even some which started with capital letter. So I wanted to neglect them also. So I said, if my first character is not underscore and my first character is not upper, I operated is upper. Is upper. If is upper is false, means it is not uppercase letter. So I selected those of this list for doing a list comprehension, and I renamed that file also as A. Although it's a new list, I renamed it is at A, and then I printed A. And what I not wanted to do is this kind of a print where every character comes in a new line. I didn't want that. I wanted that instead of new line, I print, and at the end of print I wanted to put a comma. So that is the technique of printing without going to new line, new print without, if I don't give this portion, then it will print the value I and go to the new line. I don't want to send it to the new line, so I gave this. So my output was something like this, right? And I copied that in my slide just for something. Yeah, the output has been copied here just to show you something. So this is the output that I got here. Now I wanted to show you that there are some, these are all functions, and some functions you have already used. I've shown them in blue. For example, CHR. In one of the programs yesterday, I used CHR. DIR we have already used. Eval we have already used. Help, ID, input, int, len, list, max, min, open, ORD, etc. we have already used. So we have already used some of the functions without knowing that we are using from the default built-in module. And the built-in module, of course, has many other functions. Let us see, how do we know what function does what? Some of them has very obvious names like abs. What does abs do? If I have to know, I'll just have to put help abs. Returns the absolute value of the argument. Good. Then abs of 2 is 2, and abs of -3 is 3. It's an absolute value. Okay. Then I can go about many things like bin. What is bin? Help bin. Returns the binary representation of an integer, right? So try that. Bin of say 31 pin of 31 is. Now it starts with 0b. It says it's a binary representation, and this portion is the binary representation of the 31. Okay. Then I mean there are many things we can. CHR we already know. It gives the you give the ASCII value. It gives you the character. Now this is important. Complex. Let's see what it is. Help complex. It says many things, but the first thing is that create a complex number from the real part and the optional imaginary part, right? So it creates a complex number, which means that if I give complex of say 2 and 5, it gives me a complex number. 3 plus 5j. Upijit has explained why it's not, usually we write 3 plus I5. So first of all, it is not I. In Python, instead of I, we write it as j. And not 3 plus j5, because j5 will be a name of a valid name of a variable. The computer will understand that you are talking about 3 plus a variable whose name is j5, you want to add them. No, but 5j would mean that it is not a variable name. So it is a convention. How do we represent a complex number? So 3, 5 is this. And this complex number comes with many things, like if this is a complex number, let us store that as z. Store that as z. And then, of course, we can find out the real part of this by just putting this z dot image will give you the imaginary part. Z dot conjugate is this. Can you see the difference? There are two subtle differences. That in case of real and imaginary, we didn't put this function sign, but because these are information, real part and imaginary part are just information, we just dig them out. But conjugate is an operation, something had to do, because the real imaginary part was negated. I mean, from 5 it has to be made -5, so it's a function. Okay, but the interesting thing is what abs works on this z also. Abs of z, if I put, this is the absolute value of z, which is equal to square root of 5 square plus 3 square plus 5 square. So abs when operated on a complex number, it gives you the complex number magnitude, I mean, the absolute value, that is mod of the complex number. Okay. Then there are many other, like complex. I mean, it's not important to discuss about everything. The interesting ones and easy ones I'll discuss. Like one is div mod. Help div mod first. It says that if I give two numbers x and y, it returns the tuple x. What is this? This is the quotient of x and y, and this is the remainder of x and y. So it gives me the quotient as well as the remainder. For example, if I say div mod of say 10 and 4, so what it gives me? It first gives me the quotient. 10 divided by 4, the quotient is 2 and the remainder is 2. So this is a div mod. And eval we already know. A float, you have a number here. Say if number 1, if you give float of say 1, it becomes 1.0. I mean, in Python 2, we used to use this function many often, but now it is not that necessary. And we already know, we have already used len and list, etc. Hex. Hex, you can see, you can very well imagine what it is. It's a, like bin is a binary representation, hex is a hexadecimal representation, and oct is octal representation. Like help hex, it gives you the hexadecimal representation, and that it's an hexadecimal representation is represented here. Like, okay, try hex of say 20. Up to this says that it's an hexadecimal representation, and it's 1 and 4, right? 16 plus 4, 20. Okay, so yeah, let me show you a slide. Yeah, I think I don't find I can always run the program, but yeah, see the slide. I think it will be understandable. So what did I do? In this program I just ran a loop from 20 to 29, and then I just printed decimal of I. There's just I, decimal equal to I. There is the decimal equivalent. Then I converted the binary representation simply by giving bin I, and then octal representation by giving oct I. So the output is something like this, that is shown in the other background color. You can see it from 20 to 29. You can see the binary representation as well as octal representation. Just a minute. Yeah, sorted round factor, sorted and round, and yeah, there's a function in the built-in. There's a function in the built-in. Can you see? Yes, sorted. Sorted is very similar to sort, but there's a little difference. Sorted, say I have a list. List is this is a list. What's the problem? What is the problem? Yeah, no. So this is a list, and I want to I give sorted on A. Definitely I get a sorted list. So what is the difference between sorted A and A dot sort? I want an answer from you, please. Look at the output and guess the difference between these two. Yeah, yeah, no, the other one. Shamul Bhor, you said sorted change the list itself. Let's see. So this is, look at A once again. A is not changed. Sorted gives me an output, another list as an output, which is sorted list. But the difference is A, but A is unchanged. But if I do A dot sort, this will not give me an output, but the A will be sorted. That's the difference. In sorted, you get the sorted list as an output, but A doesn't change. Whereas in the sorted function, A doesn't change, but you have a sorted list as a separate output. That's the main difference. And there's another thing that I have seen in the list above is yeah, that is sum we know already. this is something reversed. That is something which can be as well very easy to guess what it is. Say, for example, if it's A, then what is reversed of A? It doesn't tell me. It is what it is. Type of reverse of A. What it is? It is least reserved iterator. It itself is an iterator. Like range gives me an iterator. It is not itself a list. It gives me an iterator. But I can make it, of course, a list by putting a list on it. Then I can see what it is. Now you say, my A starts from 1 and ends at 56. It is just in the reverse order. So if I want to do our looping, for example, where instead of going from the beginning to the end of the loop, I want the loop to run from the end to the beginning. So I just, instead of for I in A, I should say for I in reversed A. Then you should go from the other way down. I mean, it's easy way. So this is, I think, about the round. The round. There's something called round, and we can easily guess what round does. Round of 1 point. Say, first of all, do it algebraically. X equal to 1,2.78742. This is a number, so I first say round of x. There's no brownie for point for guessing what round does. If I do it, round will be 13 because it is closer to 13. But then I can give things like, that would be rounded to the first place of decimal. Definitely, it is 12.8. I can go for a higher place of decimal also. So it's like that. Okay. So far about the built-in module. The point is that everything that is in built-in module, we can see, we can list, we can see what are the things present in the built-in modules. By using the help, we can know what individual functions are doing and we can run them. And the best advantage is that they are ready to use. You don't have to give extra path. You don't have to mention where these functions are to be found because they are placed in built-ins. Anything that is placed in built-ins are ready to be used. You don't have to mention where do you get these functions from. Okay. Now comes the other thing, that you have a module called math, which is not generally in your namespace. So the namespace is this picture. So the built-ins is there, but namespace is not there in your namespace generally, unless you do something. So, and what can you do? You can import the module in your namespace, and the way to do is, as I said, import math. When you do import math will be import, and any function which is there within the math, you have to say that the function is there within the math module, so use that function. For example, if you have to evaluate this kind of a the expression root over tan inverse pi by 3, you know pi is already there in the math box, tan is there in the math box, square root of there in the math box, but you have to specifically say that use the pi from the math box, math.pi, and then use the tan which is there in the math box, so math.tan, and use square root which is there in the math box, so that this will be the complete command. So okay, and alternatively what we could do, we could write from math import star, which means that don't import the math box, instead bring all those functions to your namespace. As I said in one of the previous slides that, yeah, your namespace can have functions. So you can directly have functions in your namespace. So just place them in your namespace. If it is so, then all this pi, tan, square root, they're available to you on your namespace. You can directly use them. Or if you like, if you know already that you will use only pi, tan, and square root, then you just input them, just square root, pi, and tan, and not everything to cluster keep your namespace clean. You just import all of them, or these three of them, and use it in your expression. Okay. But if you ask me, what is the advisable method among these three? I will say the first, because most of the time when you write a more serious program, you use simultaneously many modules. Many modules perhaps you will be using, and each module will have some functions, and there is no guarantee that there won't be clash of names. For example, some module 1 may have a function f1, and module B may have the same name but meaning a completely different functions. So if you place everything on your namespace, then the one that you put last will be the existing one. So although you are having if function 1 from module 1, the same name function 1 from module 2, you have poured everything on your namespace. But now you actually want to use function 1 of module 1. But you just said name function 1. It is clashed. It will be in clash with the function 1 which is there in the module 2 also. So that is not advisable. When you work with many modules, you keep the identities. So it is, although it looks a bit more complicated, the first one bit complicated, but that will come to you more handy when you use many modules simultaneously. But when, of course, you will be doing only one module, then it is better you use this one. You see, for simple program, for the beginners, you'll be using simply math or so, just use that. But when you'll be using more serious program, my advice is that you stick to this one, keep everything in the box, so that you won't be there will not be any confusion. Right? Okay. Now the math module I'll be talking about next, and it contains many interesting things. For example, it already contains the constants e, the value of e. E, value of e is given, pi, a constant, its value up to several decimals is given, and it contains many functions. I'll go to that. For example, import math and dir math. Gives me many other, like I want to make it. It gives me many functions. Now, some of the function names are easy to guess what it is doing. For example, a cos. People who are doing, for example, C are very familiar with this name. A cos is cos inverse. A cos h is inverse of hyperbolic cos. A sine is sine inverse. A sine h is hyperbolic sine, and its inverse. Now, interesting thing is a tan. We all know what is a tan 2. That is something interesting. Sorry. That is something interesting. We all sorry. Okay. By this time, what I did, I pressed this key in the spider, and that kills all the variable, kill all the previously imported variables. So I have to import it once again. Import math. Now the point is that it has a function called a tan 2. What does it do? It is tan inverse, no doubt. But remember that tan inverse is not a unique function. It is a multi-valued function. And say one of the reasons why we need to use tan inverse, say we have a Cartesian coordinate, we want to, so we have a polar Cartesian coordinate, we want to convert to the polar coordinate. So what is the formula? So xy will go to r theta, and r is root over x square plus y square. And what is theta? Tan inverse of y by x. But if the xy is 1, 1, tan inverse y by x has value 1. If the x is minus, xy is minus 1, then also y by x has the same value, right? So simply from the tan inverse of y by x, you cannot decide whether the angle will go to the first coordinate quadrant or the third quadrant. In that case, if you have written this program any time in your life, you know, then you have to once again put some if and check the value of x, the sign of x, to decide whether the angle will go to the first quadrant or to the third quadrant. But this problem is solved using atan2. atan2 x two argument, y and x, and gives me the value of tan inverse of y by x, right? So give, say, 1 and 1, it gives me, sorry, I have to say math dot atan2. 1 and 1 gives me a value this. This is, of course, pi by 4. It is in a radian unit. And if I give atan2 of -1, sorry, -1 and -1, okay, the angle is different. So it gives me a so usually it gives me the negative angle. So so it gives me two different results, 1, 1 and -1, -1, though they have same y by x value, but atan2 does not calculate calculates y by x, tan inverse of y by x, but also takes care of the sign, so that it knows which quadrant the angle has to be placed. Okay. And again, PIR math. Is there anything to be noted? Yeah, you can see a function radians, which converts any angle to radian. So math dot radians, say 45 degree. So my angle is in 40. So this is this. So 45 degree. So this is the, if angle is 45 degree, the corresponding radian value is 0.785, etc. And it has a corresponding complementary degrees also. If you can see, yeah, there is one degrees. So degrees and radians, you can convert between them, and you can see the functions like exp, exponential function, sine, cos, etc. are there, and you can see functions like log, log 10, log 2, etc. You can see the value of pi is given pow. Pow is power. Help. Help. It says that it has three arguments. You can see x, y, and z. So normally, if you it says with two arguments, if you give two arguments, then it gives x to the power y. But if you give three arguments, it calculates x to the power I percentage z. So that is the difference between simple power and pow. Pow, if you calculate pow, say 2, 3, it gives you 2 to the power 3, right? But if you say 2, 3, and say 5, so it calculates 2 to the power 3 and divides it by 5 and gives you the remainder. The answer should be 3. Yeah, it is 3. So that is it. That's the difference. And square root is understandable. If most of the things that we use are understandable. Yeah, I should talk about two different functions. One is CIL. The AKG has perhaps talked about CIL. Math.CIL of say uh, say 2.1. This 3. So it is an integer higher to the given number. 2.1 is, if I could, if I just used round, it would have given me 2 because it is closer to 2. But I've given ceil. Ceil is always a ceiling function. So an integer, nearest integer, but greater than the given number. And its complement is floor. So if I give floor and say give a high number, say 2.8, it will come down to 2 because the algorithm is, it gives you closest integer which is less than this given number. Okay. So I think that's the thing that I wanted to talk about. Yeah, something interesting is factorial. Yeah, there is a function factorial. Now this is very interesting. Factorial of say 4. We all know what it is. Sorry, math.factorial. Factorial of 4. We know it is 24. And those of you who have written programs for factorial in C or Fortran, you know that it's very difficult to write programs of the factor which will give you factorial of a large number. For example, factorial of say 10 is already a very large number, and factorial of 20 is a pretty large number. It seems that so far as integer is concerned, it dynamically alerts the memory and it goes on giving you the number. Factorial of 50 it dynamically alerts the number of bits, and it goes on give you a larger and larger number. So factorial can deal with, because you're dealing with integer, you can deal with very large numbers also. So I think so. This is what I wanted to tell about math.
Arunabha, there is a little confusion about POW function among our participants.
Oh yeah. Because I know why it is. Because when I use POW, I didn't use math.pow. Right? I think that is a source of confusion. Because if I give dir __ build built built-in see, there's a POW in built-in also. So actually I use the POW of built-in. The POW of built-in and POW of math, I think, are the same. So I forgot to mention math.pow.
No, actually they're different slightly. That is where the confusion really lies. Many people are thinking that in Spider or some other particular interpreter, POW does not take 3 arguments. Actually, what has happened is the built-in POW is different from the math.pow. And that is precisely why some people have actually used from math import star. So when they say POW, they get the math POW. This is one of the reasons why you should not use from math import star or any import star. Math.pow only takes 2 arguments. Built-in POW can take 3 arguments. And in built-in POW, of course, as Arunabha said, the third argument is a modular number. If you take math.pow, you will see that it takes essentially just 2 arguments.
Yeah, you're right. Math.pow takes only 2 arguments, x to the power y. Yeah. And the built-in POW takes 3 arguments. Okay. Thank you for the correction. Okay. Now I will show you another module, which is CMath. As you can see, that math module, if I want to write math.sqrt of say 2, it gives me the value of √2. And if I write math, this is equal to -2, it gives me math domain error, because there is no real number which is the square root of -2. But Python has something called CMath module, which can handle the complex numbers also. So import CMath. If I do that, has a square root. So CMath dot sqrt. If I write -2, that will give me value. You can see it is √2, and this j stands for square root. So it's a square root of √2j. So it's an imaginary number. So let me just show you one single program, very small program, that is quadratic equation. We all wrote this program in the beginning. So it is just ABC. You input ABC, eval them, the numbers, and then you calculate the roots. Usually you use, this function, you have to use if. You have to see whether the discriminant is positive and negative, and that is how you do the calculation, so that you don't encounter a math domain error. But if you have CMath in your imported CMath, then you don't really have to. You can be careless. The roots will be just coming as it is. For example, I run this program. So give this. So I give, say, 4, 1, 1. Gives me the result. See, the complex number results coming as it is. I can be careless. I don't have to give those ifs and this check on the discriminant, etc. And about CMath module, there is one thing interesting. I wanted to show you that there is something called, say for example, I have a Cartesian. I was talking about converting the complex numbers can be written, can be displayed as in the Cartesian form, like real part plus I into imaginary part. That is a Cartesian representation. Or we can represent the same complex number as r e to the power I theta, where r is the r. So there's a way to convert between the two. For example, if I have a complex number, say x z equal to complex of, say, 2 and 5. So my z is this. So this is a Cartesian representation, and from that I want to go to the polar representation. So what I do, I CMath dot polar, and I give the Cartesian polar of z. It gives me two numbers. This one is r and this one is theta. So that's it. And I can also have a opposite way by using a rect. I think it's called rect. Yeah. So that gives me back from the polar to the Cartesian representation. Okay. So far so good. Let me go to now I'll talk about another module called random, but I don't want to show because Ophichit has already talked about random. Import random and then dir random. If I do that, most of the things Ophichit has already discussed in his lecture, so I don't want to elaborate on those. Abhijit has already talked about that. I would like to show two uses of this random module. For example, this is coin toss. Coin toss. I want to simulate one function. Say I'm doing a coin tossing for the n number of times, and some of them will be head, some of them will be tail. I want to simulate that. I want a program to be written which generates the result of 20 coin tossing, and every time I repeat the program, every time I should get a different sequence of head and tail, but roughly the probability of getting head should be say 0.5, and the probability of getting tail will be 0.5 once again. So how do I do that? So from random, I imported random. You can see this program. From random, I imported random, and then I say n equal to 20, means I want to do a 20 time tossing, and number of heads I want to count. So I initialize that number head to 0. Then why should it just be n? 20 times I want to. So I run a loop for 20 times, and each time I call a random number. Random gives me a number between 0 to 1, uniformly distributed. So the probability that the number I get out calling this number is less than pH, is less than 0.5, is 0.5. So I'll call the number, and if I see the number is less than 0.5, I know the probability of getting the number greater than 0.5 is 0.5. So if that happens, I'll print head, and I'll count that number. I've got one number of head. NH, I'll set NH plus equal to 1. So one head I've got. Otherwise, I'll print tail. And finally, I'll print the number of heads thus obtained. So see. Oh, so not this one. That is why I think I made it. It doesn't give a good display. So see, tail, head, tail, head. Five heads. I run it once again. You see a new bird, a completely new sequence generated. A completely new sequence generated, and it's not guaranteed that every time you will get 5. No, there is no guarantee. Sometimes you get 4 heads, sometimes you get 7 heads, sometimes you get 3 heads, sometimes you get 3 heads. I mean, so every time you get a new kind of thing. But more or less the probability of the head is 0.5, that you can know. If you run it for a very large number, then you will find the number of heads is very close to 0.5 fraction of the total number of coin tossed. So this is about coin tossing, and I'll show you one more interesting application. It is about, this one. Value of pi from random dot. What is the theory? Theory is that, say, if I put some dot randomly in this particular square here, which is from 0 to 1 in the x-axis, 0 to 1 in the y-axis. If I put some random dots here, putting random dots means selecting random coordinates in this rectangle. And then I know, say, I'm going to throw, say, this, how many of zeros are there? 1,000 and 10,000, 10 million, 1,000 and 1,000, 10 million, 1 million dots, 10 million dots here. And if I do that, I'll just throw so many dots there. I'll generate the points over there, and I will just count that among the points generated, or among the dots selected, how many of them are in the shaded region, right? So what should be the fraction? The number of dots total generated, and the number of dots within the shaded region. That should be equal to the fraction of this area divided by the total area. And this area, we have to know it is pi 1 square. So this area by 4. So this is equal to pi 1 square by 4, and this area is 1. So if we can, the number of dots which will be there in this shaded region divided by the total number of dots, we should be equal to pi 1 square by 1, so by 4. So it is pi by 4. So if I get this ratio, how many dots are there and how many dots are within the whole box, just multiplying that by 4 should give me a value of value of pi. That's what I did in this program. You can see that I took this number, this many numbers, and then I ran a loop on this many numbers, and each time I called a random number and I assigned that random number to x and called another random number and assigned to y. So that means I am actually thinking of a xy point randomly selected within this box. Then I wanted to calculate this one, x square plus y square if it is less than equal to 1. That is meant what is the distance of this point from the origin. If it is less than equal to 1, that would mean that it is in the red region. So I should count that. I counted that. That's it. So when the loop is finished, the final value of c divided by n is my ratio that I was talking about into 4. That gives me this value. So this is another use of random numbers.
Arunabha, could I just interrupt a bit to point out that since this must have been an old function program which you used, which you ran in Python 2, right? Because that float C might confuse people, so you would want to perhaps explain that.
Necessary, yeah, definitely it is not necessary because it was written for Python 2. Yeah, that is why it was necessary. Okay, then I'll be talking about something quite different. It is called regular expression. So coming to that, regular expression is one of the modules present in the default Python that we all have in our computers. So what is regular expression? So we know that if we have a string, like this, there is a string, and we know that how to find out the substring using find command. For example, if I wanted to find out the substring cat, I should say find cat substring in the whole string. That's the find function. So yesterday we discussed about this, how to find the substring. When I clearly say what my substring is. Now, in regular expression, instead of specifying in detail my substring, I rather give a formula for the substring. For example, I import RE, and then in this string, I want to find out those substrings which start with C, end with T, and I put a dot here. Dot means anything. So it can be anything in between. So the substring should start with C, substring with end with T, and in the meantime, in between, it can be one character, but any one character. So this CAT will come, CBT will come, COT will come, and CCT will come. See, by the way to call this is re.findAll. Find all, you first mention the pattern and then you mention the string. You mention the pattern first. Pattern is C, anything, T. That is your substring. And you do that, you get it, get your answer. So findAll gives you all the substrings with that particular pattern that it finds. Okay. And on this, I'll go to my next slide. In the next slide, I give, instead of dot, I give dot star. Dot means anything. Star means any time. Star means any time. It can be 0 even. Star means even any time. So it gives me. So from this, it gives me CAT, as you can see. It gives me CAAT also. CAAT also it gives me, because anything, any time, the string should start with C, end with T, but anything, anytime in between. So that is it. Now, no, sorry. It so I'm sorry. If you do it, it starts from this C and ends with this T, and everything is as a single string it gives you. This is the output, because you said anything anytime, so it starts with C and finds anything anytime and ends with T. That is the largest substring that it can found. It gives you. But instead of that, if I give this one, say C, this one, this says this is anything, but this symbol says that only 0 times or 1 times, 0 times or 1 time. So this dot is anything, but the next dot says 0 times or any times. So you can place anything here, just one character here, and in this place also you can place one character here, 0 times or 1 times, not many times. So you can have CAT. Now you can have CAAT, because this A is 1 times, but you cannot have 3 character, for example, in between, right? So you can have just 2 character or 3 character here. So this is things going a bit complicated. Now this is an expression where ACE contains, ACE is my string, it contains many things. Alphabetical characters, numeric characters, @ hash, etc. So my pattern is this. Here R is important, R and the string. String is percentage /D. /D means digits. As I'm talking about the digits. So if I give PS, it will fetch me out all the digits that it finds in the string. All the digits, you can see from this string it finds me all the digits. And if I give D plus, then it gives me successive digits, like 1 2 3 comes as a single entity, and then 2 5 6 comes as a single entity, etc. So I can get them here by D is digit, D plus successive digits.
It seems that this part people are having some problem with.
I'll
Maybe we will discuss this again in the Q&A session.
Yeah,
perhaps if you showed them directly on the interpreter, it would be more useful perhaps for them to understand. Later on.
Should I skip the whole thing?
No, why don't you just continue, and then we can always come back to and revisit in the Q&A session.
Let me finish the whole thing.
Yeah, of course.
So I mean, because the slides will be there, and you can try it yourself with your interpreter. The slides will always be there with you. You can try them, and you can see capital D is other than digit. If D is digit, then capital D is other than digit, and plus means successive. So you get ABC here. These are digits are neglected. BCD, BCDS, you can get here. So D plus capital D is not digit. So and you can see W is alphanumeric character. All the new alphanumeric characters you can find out by W, and plus means successive. So you can see everything before this and character you can fetch out by this thing, etc. And capital W, if W is alphanumeric plus, capital W is just the complement. So anything other than the alphanumeric character, so you find out this one and this one. So okay, and D plus gives you the digit, successive digits. You get this one, 1 2 3 2 5 6 2 1 3 4 5. So if you want to restrict that, no, I want successive definitely, but not more than 4 digits. So you can write this way. So that will give you all the successive digits, but not more than 4 digits. So this 2 1 3 4 5, instead of getting 2 1 3 4 5, what you get is 2 1 3 4, and 5 is standing out because you give this. 4 is up restricted up to successive, but restricted up to 4 digits. I think then I'll be skipping this one, as this will find to be a little more difficult. Slide is there, you can always find it yourself. Now, this is interesting, that time we can play with. So import time. Time is another module which has many functions. Many functions, of which I think I will talk about just time. Just help time first. Time will tell you it's a long thing. Oh, sorry, I should have said time.time. Help time.time. Yeah. Returns the current time in second since the epoch. An epoch means perhaps the from it is the 1970 1st January, when the 1970 1st January starts. It's the start of the 1st January of 1970. How many seconds have passed so long so far? It is the time. So if I just say time.time, it will tell me how many seconds have passed since 1st January of 1970. So I call it once again. See, eight more seconds have passed. That's it. So this is one thing, and it has utilities like for example, interesting thing like GM time. GM time, help time dot GM time. I think it is easy to guess. It is the gives you the GM time, is converts the time since the epoch. Time in GM time, I think, is the, what is it? It gives tells you time of the year, everything, and yeah, everything in a single go. It tells you local time. Can we see any difference? Yeah. See, the time of the hours is 16. Yes, it is 16. So it is our local time, and this is, you can see, this is the Greenwich Mean Time. That is why it is GM time. So there are many such functions, interesting functions that we can see in the time module. Okay. Next, I will talk about. So this is about the available functions that we have in different modules. There are many other modules. We can always explore and see what are the different modules and what are the functions remaining in the module. But I think I should stop here because there is no point in showing you different modules. I rather now concentrate on something, that is how to write your own function. How to write your own function. Okay. Say, for example, I want to write my function, I create a new file. I want to write a function which should give me, for example, I know that import from math, import sine and cos. Okay, so these are readily available. So I want to write a function which will take the value of, say, a number x and would give me at a single a value of sine of x plus into cos of x. No, that's not very, sine of x plus cos x, right? So I want to write a function which will have a name, and if I just call that function, that should give me the value of sine x plus cos x. How do I do that? I have to write def. Def is the keyword that I'm going to write a function. Then the function should have a name. So let's give me a name ff. That's anything, any name can be given, and it should take a value, right? It should take a value of x, and then it should calculate everything, and then it's a function. So I have to give a compound statement. I have to give a colon, and whatever should be the body of the function should be kept in the indent, right? So it's like writing a for, it's like writing a while. You have to give a colon and then give an indentation and describe what you want to do in your function. For here, it is easy. I want to calculate some y equal to, say, sine x plus cos x, right? And return y. So let me save it in a name, my func1. My func1. So it is saved, and if I run this program, nothing will happen because there is no executable thing. I just defined a function but didn't ask the machine to do anything exactly. But my Python now knows something called ff. Ff is there in my namespace. So if I call ff of, say, 2, I'll get a value. Ff is defined. And if I want to check cos of ff, cos is already imported because I ran this program, sine and cos are already imported. So cos of 2 plus sine of 2 is this. So I'm confident that I'm doing the things right. So I can write this way. And now the point is, I can have a algebra like x equal to, says v equal to 4 and calculate f of v. That gives me a number. Now the point is, what happens when I call ff of v, I pass the value of the variable v to this function. So variable v has a value 4 that goes to the function as the value of x. As the value of x. Now when the function the program goes to the function, and the value of v, which is 4, now is passed to this x variable, which now receives a 4 value and calculates everything here, and return says whatever is returned gives me back. So I get this as a value of this. I can always store this if I like in a definite another function, z equal to ff of 4, ff of v. So my z contains this one. That is how I write my program. And the point is, this here my function is a single line function. It can be multiple line. How many lines it can how many lines you want. I mean, you can write a very multi-line programs, and also you can have multiple. These are called arguments. These are called arguments. X is an argument of this function, and there is no restriction. You can have x, y, z. For example, you could write a function like x, y, 2 arguments, and instead of this, you calculate this. It is also a valid function. So when I do this, so I calculate w equal to 3. So write v and w. Now my function takes 2 arguments. So I have to supply 2 arguments, v and w. Both of them can be same I also. So that it takes this. So the point is, you can have multiple arguments if you like, and I mean there is no restriction. You can have multiple arguments. What we have to understand here, that if even in this case, I was very careful about not to give the same name to these arguments and by which I'm calling it. Say, for example, I'm calling it by v and w, and here they are x and y. The point is, even if we call them by the same name, they are actually different variable. For example, if I say make the problem simple. This is my program, right? Okay. Now I say x equal to 10. I call ff of x. So I pass the value x10 to x. Now what happens? The 10 value goes to the function, and then in the next go I set x equal to x minus 2. So the value 10 becomes 8. Then it returns me x square. So value of y is x square. Expected I'll get a value 64.
You get an error because you defined it with 2 arguments.
Yeah. Okay. Yeah. Expected I'll get the value 64. Yeah, I got this value 64. But what happened to x? What happened to x? X is still 10. That is what I wanted to say, that though this x and this x has the same name, but they are different variables. The value 10 is passed to this function, and then it has got no more connection with this function. This is a local variable. This x, although has the same name, it's a different variable. It's called a local variable. Now, if the local variable x, it receives the value 10, it makes it 8 and calculates on 8, but it cannot change the original value, the value which is passed to it. It doesn't change that. So it's a local variable. Now, yeah. Another thing is that, I was writing this one, say, okay, y equal to this, z equal to the x cube, and I want to, this is also allowed. This is also allowed. So it means I can return apparently multiple values. I can return apparently multiple values, but if you are careful enough, looking at the output, you can see it's not multiple values, because when I said y is a comma z, actually what does it do? It packs them into a tuple and gives me back a tuple. So it returns one single entity. Return is always a single entity. It returns me one single thing. That's a tuple in this case. So I get 64 and 52 packed into a tuple. But apparently it looks like that I can send back, return back multiple values packed in a tuple. Okay, I can always do that. And there's something called a local variable. Okay. I'll show you an example, global variable. I'll show you an example. Yeah, look at this program. I've defined this is a function which takes a value x and calculates a star x and returns x. But the value of a is not passed to it, but the value of a is defined in the main variable. So it takes the value from there. So although the global variable is not defined in here, so if any variable is referred which is not defined over there, it looks in a caller program if the variable is already defined. If the variable is already defined, you have already in your namespace such a variable defined has a value, you can use that. So that's called a global variable. Although it is not within the function, it uses from the namespace, it uses this variable. So this is something which we have already discussed. But this is of course an error. You can see it takes only x, and then this step will definitely be okay, because the value the group from the namespace it will take the value a, and then if you want to do this kind of a thing, then it is objectionable, because now it seems that a is a local variable. It seems that a is a local variable, so you are using a value of the local variable before it is defined. That is not allowed. So if it's a local variable, then it has to have a value defined before its use. That is it. And now I come to default argument. Say, for example, I want to write a program, say, I calculate sine of simple program, sine of nx. So what I have is equal to sine of nx. Okay. Defined. Now I can call this. It takes two arguments, so I have to give the value of x, and also I have to give you the value of n. Say for example 2, and it gives me a value. I can change the value of 2 instead of 2. I can write say 4. It gives me another value. Right? Now I can write this way, that we have seen in many Python functions we have already encountered, where a function can be called with one argument, with two arguments, with three arguments, etc., etc. Now, how do you write it for your own Python function? You can write n equal to 2 here. That means that this becomes a default argument, right? So that means that you can call this function with a single argument. If you just give one single argument, say ff x, what is the value of x, by the way? It's 10. Okay. Make it simpler so that we can understand. X to the power n. Okay. Now, say x is 10, so call x. I called it with only one argument. So what happened? Second argument I did not specify, although the function takes two arguments, x and n, but I didn't specify the second argument. So I defaulted for the second argument. And what happened? The n equal to 2 is taken. That's called default argument. That if you don't specify the value of an argument, it will take a default value. But you have the option of prescribing the value. For example, x1. It's 10, x3, it gives you 1000 perhaps. Yeah. So you have the option of giving the second argument, But you can also default it, because by default you have already prescribed another value. So now make it slightly different, like x equal to and m equal to say 3, and I want here to be m star. So now it's a function which takes 3 arguments. I can call ff say x, 3 and 2. Should give me 2000, right? What's the problem? If it takes 1 to 2 position. What's the problem?
The problem might be
The problem is the y is not defined here.
Why should be defined within the
no.
program?
The problem is something else. The problem simply is that in the newer versions of Python, I'm not very sure whether that has already been done, but the idea was that with default variables, values with default variables, that was in the Python well, plan for a long time. I'm not sure whether that has already been implemented, that default variables should always be named variables. So you have only one positional variable.
Yeah, x.
X is the positional variable. You have only one
variable.
output.
Yeah.
And the other two variables are not positional variables. They have default values. Now, earlier versions allowed you to still treat them as.
Oh, I see. Now I can see.
Now they have to be called with name.
Now I can see. You cannot call this way.
Yeah,
you cannot call this way, right?
I'm not sure, but this was in the plan for a long time. But you can.
Working. There was some typing mistake. So I can call it with 3 variables. You can see. I can call it with, say, x2. What happens?
Oh, okay. I can tell you exactly what went wrong. What went wrong is that you did not run the file up.
Oh, I see.
So that's all that went wrong.
So now you can see I can run this program with single variable, say x. I can run the program with single variable. It takes the default value n equal to 2, m equal to 3. I can run this with x, x4. So it takes n is the second argument. It takes as a value of n, right? So it gives 3 into 10 to the power 4, right? Yeah, that's it. And now the problem is, if instead of changing the value of n, I want to change the value of m, right? So apparently there is no scope, because I have to, if I want, how do I know it's a third variable that I'm going to change? So the trick is that you put m equal to 5. So you're calling it with 2 variables again, but now you're specifying which variable you are going to change from its default value. 2 variables are there which has default value, but now you are changing the value of m, which has a default value of 3. Now you are changing it to 5, right? So this is called default value. So the function with you know how to write functions, you know how to write default variables, and you also know how to write named variable, keyword arguments. With this keyword, you can definitely specify which variable you want to put the value of. So these are these things. Now lambda functions. Lambda function is this one. Say, for example, many times you don't want to specify define a function, but don't want to define it through def. It should be a simple one-line program. So you can write this one instead. This will also define as a function. I think the way to do it is like this. So I have defined a function f, which is a function of x, which is this function 1 by 1 plus x. I could have defined this way, going through def f, but it's such a simple function that I don't want to go to this detail. In the function itself, I just want to write a one-liner code like this. If equal to lambda is a keyword which says that I'm going to define a function of x such that it is just 1 by 1 plus x. That is my definition of the function. It's just defined in simple one line. You don't have to go to def and other things. You can define it straight away in a small line like this. So yeah. So I think so far I have covered the points that I wanted to mention, and then I have to go to a more complicated concept like object-oriented programming, but that would be a slightly difficult one. So before going to that section, I'd like to we'd like to have some discussions if it is necessary.